We have all been there. You are staring at a digital waiting room, hovering over the refresh button, hoping to secure a seat for the biggest concert or match of the year. In that queue, most of us operate under a basic assumption. If we simply wait our turn in line, we will eventually reach a checkout page and buy a ticket at its advertised static face value. But that fixed price is largely an illusion. Today, major live events are governed by dynamic pricing engines, algorithms that adjust the cost of a seat in real time based on immediate market conditions. When tickets opened for the 2024 Oasis Reunion Tour in the UK, seats originally advertised at €160 jumped to €400 within a matter of minutes. This means the fan is entering a competitive environment, where the final price is determined by how the platform's software interprets the collective behavior of the crowd. To run pricing models on a global scale, ticketing platforms rely on high-throughput data pipelines, specifically utilizing streaming architectures like Apache Kafka. These systems update live inventory continuously, processing thousands of data points without system lag. This visualization shows the telemetry the system tracks. The engine identifies web traffic surges, measures queue lengths, and tracks conversion rates. By instantly calculating these inputs, it establishes the maximum price a consumer will tolerate before abandoning the purchase. This creates a friction point within the checkout cart. To display transparency, platforms use an all-in model, clumping the base ticket price together with mandatory service fees. But those service fees are frequently calculated as a percentage of the base price. Because the fees are percentage-based, whenever the engine drives the base cost of a ticket higher, the total dollar value of the fee collected by the ticketing platform grows as well. This structure provides a financial incentive for the software to prioritize high-margin transactions, turning a routine ticket sale into a high-speed yield management operation. The real algorithmic work doesn't just happen during the sale. It starts months before an event is ever announced to the public. Modern sports franchises now utilize proactive artificial intelligence, deploying insurance-grade risk intelligence. They use actuarial models, originally developed for the insurance sector, to forecast consumer demand and minimize revenue uncertainty. This radar chart illustrates the datasets these neural networks ingest to construct predictive curves. The AI weighs historical sales pipelines alongside social media sentiment, local weather forecasts, and the current performance of the team. The Golden State Warriors implemented a predictive demand system that analyzed over 50 variables, including localized highway traffic conditions. That specific integration predicted ticket demand with 92% accuracy, contributing to a 27% increase in revenue for high-demand games. Through this AI ecosystem, the unpredictable nature of fan loyalty and human behavior is translated into controllable variables, designed to de-risk the corporation's bottom line. However, these predictive models depend entirely on the accuracy of their market assessments. During the 2025 FIFA Club World Cup in the United States, this hyper-commercialized strategy failed to account for local reality. FIFA scheduled matches in massive NFL stadiums, while setting initial price floors at levels the US soccer market wouldn't support. When a dynamic pricing engine encounters a high volume of unsold inventory and low demand, the software executes rapid, unannounced downward price corrections to fill the empty seats. This chart tracks the price action for the semi-final match at MetLife Stadium. Just before kickoff, a ticket the algorithm previously held at $473 crashed to just $13, a 96% depreciation in value in a matter of hours. This extreme volatility suggests that these systems prioritize rapid revenue adjustment over the establishment of a predictable, accessible market for regular fans. To prevent secondary market fluctuations and maintain exclusive control over the entire life cycle of a ticket, organizers are migrating their infrastructure onto proprietary Web3 blockchains, such as Avalanche. By locking authenticity to a private blockchain, FIFA forces ticket resales through its own internal exchange. The organization then extracts a 15% commission from the seller and another 15% from the buyer on every single trade. But the most significant change is the introduction of the Right to Buy token, or RTB. An RTB is not a ticket. It is a digital asset functioning as a conditional call option. It grants the exclusive right to purchase a face value ticket only if a specific team advances. Fans commit capital up front. If the team is eliminated, the contract expires, the token becomes worthless, and the organizer retains the initial purchase price. This shift towards financializing the fan experience has triggered a multi-front regulatory crisis. A coalition representing over 6 million European consumers recently filed a complaint before the European Commission, accusing FIFA of using opaque algorithms and pressure-selling tactics. Simultaneously, the Swiss regulator GESPA filed a criminal complaint regarding the blockchain platform. They argue that requiring a monetary stake for a probabilistic payout classifies these tokens as a form of unregulated sports betting. As these blockchain-based derivatives and dynamic engines face mounting legal pressure, the future of the stadium seat depends on whether regulators can keep pace with the software. For now, the seat is no longer just a place to watch the game. It is a volatile asset in an automated market.